Hello everyone, welcome to the HCIP OpenELVR certification course. Now let's continue to learn about OpenELVR storage management. In the previous section, the Gluster FS basic environment has been set up and a replicated volume has been created to test the service. From this section, we will complete the creation of all three types of volumes and learn the key parameters involved in the creation of volumes. Now, let's learn about the experiment.
First, let's look at the first type, the creation and use of distributed volumes. Before creating a volume, run the pool list command to check whether the storage pool is faulty. So now we enter Gluster pool list, the current storage pool status, and the 6 nodes are normal. And then we start to create distributed volumes. The command for creating the distributed volume is Gluster volume, and then create, and the distributed volume name. In this example, the name is GV-DIS. The following is the volume type. The created distributed volume is the most basic volume by default. Therefore, you can enter nothing in the volume type. It indicates that a distributed volume is created. And then we enter the address of the break. Enter the planned breaks. Node 1, column EXP VDB1 break, and break of node 2, VDB1 and break. And then press enter. And after creation is successful, let's take a look at the information about it. We enter Gluster volume info. You can see that the creation is successful and there are 2 breaks, namely DB1 of node 1 and node 2. If the status is create, the created status is created. So we need to turn on the value and we enter Gluster volume start. And then the volume name, GV-DIS, and press enter. After the startup succeeds, the message successful is displayed, and we check the info information again. It's found that the status is started. So after the distributed volume is created, we need to mount it on a client. On a client, you need to create a folder and mount the volume to it. To facilitate understanding, we use make directory, mount, GFS, and this is the mount point. And then let's mount it, mount-t, and the type is Gluster FS with the volume address. And then node 1, GV-DIS, and the mount point is mount GFS-DIS. And then we run df-h to view the mounting results. The mounting is successful and the space is 4 gigabit. This is because the distributed volume is created. the distributed volume has 2 bricks, each with 2 gigabit. Therefore, the total space is 4 gigabit. And then we go to the mount directory and write a few test files here. According to the lab guide, 5 files are required for the test. Each file is 40 megabyte. Its recommended line is dd if equals /dev0. When we need to create several files and check the disk space usage, therefore we only need to generate several large files and do not need to write specific details to them. So -dev-0 means none. And then OF equals to mount, GFS, and disk. And slash. Where is refers to the out, that is the place where the output file is generated. And the file name is test1.txt. It's generated in the mount GFS disk. And then we use BS to specify the size equals to 1 megabyte and the count equals to 40. That is the 1 megabyte files, 40 files. That is 40 megabyte. And then you can see that the speed is 778 megabytes per second. That is the first 40 megabyte. And then we were going to write the second. We're going to change the name, the second, and then the third, the fourth, and the fifth one. Alright, let's run the ls command to check the test.txt file. There are 5 txt files. The floater is 200 for 800, but the unit scale in the lab guide is 200 megabytes. That is because the units are not uniform. This is the disk space. And then let's look at the mounting information. The 335 megabyte file is used now, and the 135 megabyte file is used before. This indicates that a 200 megabyte file is generated. And then we go back to the bricks of node 1 and node 2 to see if there is any file information. In node 1, we switch to the directory and use ls command. You can see that there are file 1, file 3, and file 4. And then we turn to node 2. There are file 2 and file 5. So that is node 1 has file 1, 3, 4, and node 2 has file 2 and 5, which happens to create all the files. As we mentioned in the previous course, a file in a distributed volume can only be placed in one of the 2 bricks, and the load sharing cannot be selected. Therefore, there are 3 files in node 1 and 2 files in node 2. This is the first use of distributed volumes. And next, let's create a replicated volume. As mentioned before, the command for replicated volume is cluster volume create and then the volume name gv-rip. The replicated volume uses 3 copies, therefore you need to enter the volume type replica and the number of copies. When we make the test volume, we have 2 copies, but in this case, we have 3 copies, so that's why we entered 3. And according to the planning, we create the copies to node 1 VDB2 breaks and node 2 VDB2 breaks, and then the breaks of node 3. And then we check all these breaks in VDB2 partition. And then we press enter. So now we will finish creating. And after the creation is complete, we run the cluster volume start and the name gv-rep command to start it. And after startup is successful, we check the information about cluster volume info. And then the IEP, there are 3 breaks. It says here that 1 multi 3 equals to 3. There is 3 breaks, such as 1 multi 3 is 3 copies, and also we can see 2 multi 2 later, which will be introduced later. And now we can see that it has 3 breaks, and next we mount it on a client to see how it's used. First, we create the mount point. It's also make directory -mount -gfs IEP. And then we mount it mount -t cluster fs, and then node 1 columns gvrep, and the mount point is mount gfs rep. After the mounting is complete, we run df-h to query the space used by the disk array. The space used by the disk array is 2 gigabit. I have used 3 breaks, and each of them is 2 gigabit. Why? Because the total space should be 6 gigabit, and it's a 3-copy replicated volume, so here we will only have 2 gigabit for free space. And next, let's go to the RIP folder and create the new files. The preceding command is the same as the preceding process. And it's also 5 files need to be created. Okay, after the creation is successful, the query results show as there are 5 files. And then we're looking at the disk information. It has reached 268 megabytes of the disk usage, compared with 68 megabytes initially, so now we're using 200 megabytes of extra space. And then we go to the corresponding node to check whether the break has the information we want. And in the breaks of VDB2 on the node 1, you can see that the breaks 1, 2, you can see that the files 1, 2, 3, 4, and 5. And then we go to node 2. and there are 5 of them. And then we look at the node 3. Which is also 5 files. So at this point, we can prove that it created 3 copies and each one has a corresponding message. So this is the replicated volume. After creating our replicated volume, let's put distributed and replicated together, turn it into a distributed replicated volume for demonstration. We run the cluster volume create. The name is gv-dis-rep. In this command, dis indicates distributed and rep indicates replicated. So the name is dis-rep. And when we say that the distributed replicated volume has both distributed and replicated volumes, and also we said that in a distributed replicated volume, it first creates a subvolume form by copy volumes, and then distributed volume format for subvolumes. So what we need to know is the number of breaks we need to use. If I want a 2-copy distributed replicated volume, I need 4 breaks. So we enter replica, and then the number of replicas is 4 breaks. Therefore, we select 2, and then creating the 2 volumes. Besides this, you must write in the right subsequence because the 2 adjacent volumes will be used as replicated volumes. And therefore, we enter the node 1 VDB3 break and node 2 VDB3 break, and then node 3 and node 4. And finally, there are 4 nodes, each using the VDB3 partition. And then we press enter. Now it's created successfully. And after the creation is successful, we run the cluster volume start. dis-rep. After the function is enabled successfully, we run the cluster volume info command to query the information about the function. Let's see. Here it's write 2 times 2 equals 4. It's based on the 2 times 2. The second node is a copy of the software and the first one is a number of distributed volumes. Therefore, the software is a distributed replicated volume, and the number of copies is 2. Therefore, the software has 4 breaks. And when we configure the volume, we find that the configuration command is the same as the replicated volume. However, if the replicated volume is 2, you only need to follow 2 nodes. If the replicated volume here we write 4 nodes, it means copy of 2 nodes. And then we run the make directory mount gfs and dis-rep command on a client to mount and verify the mount point. And then we mount the cluster fs node 1 gv-dis-rep to mount gfs dis-rep. And then we tap the mount point. Okay, after the mounting is complete, we query the result shows that the space is 4 gigabit. The 4 breaks are used, although the total space is 8 gigabit, but 2 copies are created, so the space is 4 gigabit. And then we create a few more file information, which we quickly creating use historical commands. Then check the result. There are already 5 files for test. And then let's look at one of its space usage. It's also 200 megabytes. And then we return to the node and go to the node 1, for example, to query the values. And then here in node 1, it have 3 files, 1, 3, and 4. And then we turn to node 2. Node 2 is also file 1, 3, and 4. That is, node 1 and node 2 are the same. And then we go to node 3. Here the files of node 3 are 2 and 5. And then for node 4, node 4 and node 3 are the same. Therefore, the 1 and 2 are the same, 3 and 4 are replication volumes. That is use of distributed replicated volumes.
So far, we have completed the creation of 3 types of volumes: distributed volume, replicated volume, and distributed replicated volume. In the process of creation the 3 volumes, we have learned a key parameter, replica, which directly determines the number of copies. And you need to remember this parameter clearly. In the next section, we will create the remaining 2 types of volumes, and then we will practice add breaks, delete breaks, and test disaster recovery. Thank you for watching.